Welcome to our decision theory analysis presentation. In this project, we explore the growing issues around obesity and explore factors which contribute to this crisis. We are postgraduate students pursuing a master's in business analytics from the National University of Ireland, Galway. Our team consists of Prajakta Shinde, Madhura Dhatavkar, Namrata Desai, Alex Zanella, and Varun Dua.
Our goals: identify an object of research and define the problem statement, extract valuable information from public or open data sets, effectively communicate information to identified relevant audience, gather evidence to support business decisions, present insights on trends or opportunities within the context, use Tableau to design interactive visual dashboards.
Obesity is a major growing health concern around the globe. Governments, NGOs, and pharmaceutical companies are grappling to find insights to tackle the growing lifestyle disease. Our objective is to find relevant factors affecting obesity and improve understanding of how managing such correlation might affect the same. We will look at the following factors: number of fast food restaurants in the vicinity of the population, indulgence in physical activity by the population, consumption of a certain portion of fruits by the population. Additionally, we will investigate the relevance of any insights thus gathered for our target audience and help them develop marketing campaigns for anti-obesity drugs and policy for government campaigns. Before we move on to our analysis, we would like to define the target audience, which we intend to address and who can utilize the information in developing better business or policy decisions. First one is Government Health Department. Goals are prevention of obesity through directed societal change, enable efficient government programs across the country to raise awareness of health and obesity. Long-term milestone: foster healthier lifestyle. Second one is a generic drug company. Goals are define targets and micro action plans based on insights from each state. Increase market share and revenue for the anti-obesity drug. Find qualified prospects.
We gather the datasets from the Center for Disease Control and Prevention (CDC) website and public available data-finite data from kaggle.com. We use the following datasets: CDC Obesity 2017, USA State Population Census, CDC Activity Data 2017, CDC Fruit Consumption Data 2017, Data-Finite Fast Food Restaurants Data 2014-2019.
We modified the data on fast food restaurants to keep relevant information for our analysis. In doing so, we removed unwanted columns from the master dataset. The Data-Finity dataset on fast food restaurants contains 28,577 unique records, which constitute approximately 12% of the total actual number of fast food restaurants in the United States of America.
In the following map, we can visually observe the problem of obesity in the United States of America. The size of the dot represents the percentage value of obesity from that state. For example, 36.5% of the population of the state of Oklahoma fall under the obese category, while 33.2% of the population from North Dakota is obese. In numbers, North Dakota has a population of approximately 755,000, and out of this, approximately 250,000 people are obese, which is a large number. From a superficial analysis of the map, eastern states in the country, for example, Texas, Oklahoma, Wisconsin, seem to exhibit a greater prevalence of obesity than western states like California, Nevada, and Montana. Now, before moving ahead with our exploration, we want to make sure that the fast food restaurant data set we have, which has 28,577 number of fast food restaurants is evenly distributed across states in the US. The sample that we have of 28,577 is roughly 12% of the actual number of fast food restaurants in the country, and thus we think it's important to ensure that the sample we have is properly representative of each state. To do this, here in this map, we try to see if the data of number of restaurants in our sample matches the density of population in the corresponding state. For example, California here is one of the most densely populated states in the US, and our data has the greatest number of fast food restaurants in California, that is 2,478, while Montana is one of the least densely populated regions. In this, we have only 90 fast food restaurants in our dataset. The dark blue color here, like in California and Texas, represent greater populations, while lighter blue and green shades represent less population. Visual analysis of the dashboard leads us to presume that the restaurant data is sufficient and relevant for each state based on its correlation to the state's population. We will proceed on our analysis based on this presumption.
One of our goals with this project is to determine whether there is any correlation between obesity levels and the number of fast food restaurants. In order to explore this question, first, we gathered the obesity percentage of adults aged 18 years and above in each state and compared this percentage with the number of fast food restaurants available in the sample dataset. The following data visualization, created in Tableau, will help us to analyze the relationship between these two measures and gain insights about the same. For example, California here has an obesity percentage of 25.1 and the number of fast food restaurants is 2478, and similarly for other states. Our intention with the bubble map feature is to easily visualize the size of the distribution of the number of fast food restaurants in the corresponding state against its obesity percentage, displayed in the bubble label. The greater the bubble size, the greater the number of fast food restaurants in that corresponding area. Example, Texas, with a larger bubble size, has more fast food restaurants than Georgia, which has a smaller bubble size. Narrowing down our focus to California, it can be noticed that although having the highest concentration of fast food restaurants in the country, this number does not directly affect the obesity level of its population. In the obesity rank by highest percentage, California stands on position 49 out of 52 states. Only 25% of its population is classified as obese. Thus, this comparison seems to be a little flawed because the density of the population these fast food restaurants cater to should also be taken into account. We thus proceed to compare the obesity levels with the number of fast food restaurants per head. In order to normalize the impact of population size in our research, we created a calculated field in Tableau named number of fast food restaurants per capita to divide the number of fast food restaurants from our sample dataset by the state's population in 2017. Next, with this new measure available, we updated our plots. Larger, darker squares represent higher per capita fast food restaurants, and the number inside indicates the obesity levels. For example, West Virginia, South Dakota, Alabama, Indiana, Ohio are the largest and darkest squares, representing the highest number of fast food restaurants per head. They're also one of the most obese states in the US, all ranging from an obesity percentage of 32 to 38%. While states with smaller number of fast food restaurants like Massachusetts and New York with obesity percentages of 25.7 and 25.9 respectively. This chart, however, does not reveal the correlation perfectly. So we now look at a bar chart to drill further. We see a bar chart here depicting obesity as the width of the bars and fast food restaurants. For example, Alabama is wider than New Jersey, which has smaller obesity percentage, and thus is a thinner bar. The x-axis are the states in the US, the y-axis is the calculated field of population divided by number of fast food restaurants. Thus, a state like South Dakota has 0.000187 number of fast food restaurants against one person in the state. We see relatively thinner and shorter lines on the left side of the chart, with the exception of Texas, Mississippi, maybe Michigan, and Wisconsin, and thicker and longer lines on the right-hand side of the chart. Thus, bars on the left indicate lower obesity levels corresponding to less per head fast food restaurants, and right side depicts higher obesity levels against higher prevalence of fast food places. This indicates that generally, states with lower access to fast food restaurants exhibit lower levels of obesity than states which have higher access to fast food restaurants.
Next, we would be considering the available data set for physical activity being performed. The data confers population from various parts of the United States of America performing at least 150 minutes of physical activity per week. For example, in a state like Nebraska, 49.4% of the population indulge in more than 150 minutes of activity per week, and the corresponding obesity percentage is 32.8, while a state like Colorado, where almost 59% of the population indulges in more than 150 minutes of activity, has less obesity percentage of 22.6. The size of the dot here represents obesity. So, Nebraska with higher obesity levels has a larger dot than Colorado. Through visual analysis of the map, we observe that states with a higher percentage of people involved in the activity exhibit lower obesity levels. For example, most of the states towards west of Montana to New Mexico have activity percentages greater than 50% and corresponding obesity less than 30%. On the other hand, states to the east of Montana and New Mexico exhibit higher obesity levels. To get a better view of this, next we look at the following charts. Here we see two tables depicting the comparison of obesity levels in the states with greater than 50% or less than 50% of the population indulging in more than 150 minutes of activity. Most of the states on the left hand side here exhibit less than 30% obesity, while on the right hand side here exhibit greater than 30%. On the left hand side, 7 out of 10 states exhibit less than 30% obesity, while on the right hand side, 8 out of 10 states exhibit more than 30% obesity. Thus, higher levels of activity seem to be reducing obesity percentages, evident from states in the left hand side table. Based on these observations, it seems that more than 150 minutes of physical activity per week has a strong negative correlation with obesity.
Next, considering the data for fruit consumption by the people in United States America. The data set uses population consuming less than one or more than one fruit in a day. Looking at the map for fruit consumption here below, the size of the dot represents percentage obesity levels and the label data represents the percentage of people consuming more than one fruit per day in that state. For example, a value of 60.6 in Texas represents the percentage of people having more than one fruit in a day, while with 33% obesity. While in a state like Wyoming, 62% of people consume more than one fruit and have a lower obesity percentage of 28.8. Comparing a state like Vermont here, which has the highest fruit consumption in the country, a whopping 70%, has an obesity percentage of only 27.6, while a state like Oklahoma has obesity levels of 36.5% and fruit consumption is around 54%, almost 16 points less than Vermont. Drilling further into this data, we can see in the bar graph above the trend of fruit consumption and obesity. Width here again represents the obesity percentage and the height represents a higher percentage of fruit consumption, the graph being in ascending order of fruit consumption. The y-axis is thus percentage of people having more than one fruit a day, while x-axis the state. We see thicker and shorter bars on the left-hand side of the chart depicting lower consumption of fruits against higher obesity and relatively thinner long lines on the right extremes depicting higher fruit consumption against lower obesity. It does not, however, show a very strong correlation which can be gauged from the middle parts of the graph, where there is no clear distinction between some of the bar lines, but we do see a weak trend nevertheless.
Now, looking at the comparison of the top 10 states from each category, that is, states with highest fast food restaurants per head, this chart, then states with lowest percentage of fruit consumption, this chart, and states with lowest percentage of people indulging in less than 150 minutes of activity per week, this chart. The label value on all the charts indicate the obesity percentage of the states. For example, in Alabama, the label value is 36.3%, while the concerned parameter on the y-axis, like here, the fruit consumed is on y-axis. A state like Alabama appears in all these charts. So does a state like Kentucky. Most of the states appear in at least two of the three charts. For example, Oklahoma appears in lowest fruit consumption and lowest physical activity top 10. Low physical activity, low fruit consumption, or higher access to fast food by themselves show a correlation to higher levels of obesity. When considered together, they become even stronger factors affecting obesity. Our key takeaway point is, as said before, most states on the visualization here appear in at least two of the three charts, which means we can see a pattern on how these three life choices, fast food consumption, physical activity, and fruit consumption, are linked to one another. States which show low fruit consumption also exhibit higher fast food restaurant availability, or lower physical activity levels, or both. And as we have seen, all these factors affect obesity percentages adversely. So based on our analysis and observations, our recommendations would be as follows. For policies, we see a trend that states with lower fruit consumptions have higher access to fast food restaurants. Hence, policy decisions like tax breaks to healthier dining restaurants or juice bars, reducing cost and tax on local fruits to improve cost effectiveness of such fruits, advertisements on how increasing consumption of fruits helps in reducing obesity levels, consumer awareness, involve stakeholders like big fast food chains to come up with healthier fruit-based snacks. Next, we see a trend that states with low fruit consumption also depict lower physical activity levels. So, increase consumer awareness on fruit consumption and physical activity, encourage schools to provide healthier meal options and mandatory physical activity sessions. For drug companies, design marketing campaigns in different states with cross-sell options. For states with lower physical activity levels, we can market a supplement for improving energy levels, that is, for a better active life. For states with low fruit consumption, we can market a supplement of vitamins. Design campaigns around the fact that lower fruit consumption and low physical activity levels could be factors leading to obesity, and market the drug as a prevention against such an outcome.